RP2.
Go.
RP1.
Go.
Vehicle electrical.
Go.
Telemetry.
Go.
RF.
Go.
Complex system.
Kistler Aerospace Corporation is developing fleets of reusable single-stage to orbit rocket ships to support commercial space activities as pervasive as today's aviation industry.
7, 6, 5.
The mission profile of the Kistler spaceship is a vertical takeoff,
Liftoff.
followed by insertion into Earth orbit. For enhanced payload capability, early versions will employ fully reusable launch assist platforms that return to the launch site ready to fly again. All of the fuel necessary to put the entire ship and payload into space is carried on the vehicle.
Pitch program is in. Chamber pressures look good. We have a
In space, Kistler rocket ships coast and maneuver as required to perform their mission, such as inserting satellites into orbit or providing logistic support for space facilities.
Things all look good at this point. Continuing to just...
To land, Kistler rocket ships do a pitch-over maneuver and deorbit burn to reduce speed. Air brake during re-entry. Slow to landing speed with rockets. Then gently touch down on specially prepared landing pads. These fully reusable Kistler rocket ships have the potential to revolutionize space transportation and open up the space frontier for humanity.
Let's take a look at a typical Kistler launch profile. Kistler uses innovative technology to save costs at every stage of the mission. The Kistler K-1 is a simple two-stage design vehicle assembled horizontally rather than vertically. This way it's easy to service and transport. At the launch site, the K-1 is raised vertically and fueled just prior to liftoff. Instead of using dangerous liquid hydrogen, the Kistler K-1 is powered by an efficient liquid oxygen and kerosene fuel system.
3, 2, 1. Ignition. Liftoff. We have liftoff. Liftoff of the Kistler Aerospace K-1 reusable launch vehicle.
The K-1 lifts off and ascends to an altitude of 135,000 feet before separation of the first and second stages occurs. After separation, the first stage fires its center engine to return to the launch site. A parachute system is deployed for safe return back to Earth. Cushioned by airbags, the first stage lands gently on the ground, where recovery crews quickly retrieve the vehicle and begin servicing it for the next flight. Back in space, the second stage fires its engine and moves up into low Earth orbit. The orbital maneuvering engines fine-tune the orbit of the K-1 vehicle, and the payload compartment opens up to release the satellite package at the desired position. The nose cap closes, and the second stage then prepares itself for return to Earth. Approximately 24 hours later, the orbital maneuvering engines are fired once again, and the K-1 moves out of orbit and re-enters the atmosphere. As the vehicle heads back towards the Kistler launch base, a parachute system is deployed in preparation for landing. Again, using airbags, the K-1 returns gently to the ground. It too is serviced quickly and ready for the next launch.
Back in 1993, a company was founded by a guy called Walter Kistler. He'd had a long history in the space program, having designed critical instrumentation for early spacecraft such as the Agena upper stage. The Kistler team was actually full of a whole bunch of Apollo veterans, including George Miller, who's sometimes referred to as the father of the space shuttle. But their plan was to build a reusable launch vehicle. It was the Kistler K-1. And in 2006, it was one of two companies awarded a NASA contract to develop orbital transportation services. The other was a little-known company called Space Exploration Technologies, or SpaceX for short. Now, at this point, SpaceX was still trying and failing to launch the Falcon 1, but it had announced plans for the Falcon 9, and it would be 5 years before SpaceX announced their plans for reusable rockets. The Kistler team, on the other hand, had spent 10 years designing their reusable rocket, the K-1. However, without any revenue, they'd actually run out of money and declared bankruptcy in 2005. But in 2006, they would merge with the suborbital startup Rocketplane Inc. to form Rocketplane Kistler. This new lease of life let them compete for the Commercial Orbital Transportation Services program, and they won a $200 million contract. And with that infusion of cash from NASA, they began signing contracts to build and test their vision of the future. The K-1 launch vehicle was a two-stage, fully reusable rocket. The overall mass was about 380 tons, and it would be about 37 meters long. The first stage was called the Launch Assist Platform. It was 18 meters long, 6.7 meters in diameter, and it would be about 250 tons when fully fueled at launch. The second stage was about the same length. It was actually slightly longer, 18.6 meters, and but it was a whole lot narrower. It weighed 130 tons fully fueled. Now, the first stage used 3 liquid oxygen kerosene engines, and the second stage would use a single engine. All of these main engines were derived from the NK-33 engines. The NK-33 engines, if you remember, were originally developed for the Soviet N-1 moon rocket. And yes, while the moon rocket was not the most successful, the engines on paper were the best engines in the world, with really high specific impulse and really amazing thrust to weight ratio. And it was only because it was politically inconvenient that they'd never really flown. They'd ended up getting stuck in a warehouse for 30 years until the end of the Cold War, when Russia was looking around to sell things. They said, hey, we've got these really, really good engines. So Aerojet, of course, took these engines, they modernized them, they added new electronics, new hydraulic gimballing capabilities, and these were then sold as Aerojet engines, such as the AJ26 series. So the launch profile would have the first stage rocketing up to about 43 kilometers at a velocity of 1.2 kilometers per second, where stage separation would happen. The second stage would, of course, continue on towards orbit, but the launch assist platform, the first stage, would then flip around and reignite its engine to head back to the launch site. Now, to land, it wouldn't use rockets like the SpaceX Falcon 9s. Instead, they envisaged using parachutes and airbags to absorb the landing force. And they figured that they could have a quick turnaround if they could land these things. The second stage, the second stage would continue to orbit on the main power. Again, this would be a kerosene liquid oxygen engine. But once it got to orbit, it would use a different orbital maneuvering system that would be fueled by liquid oxygen and ethanol. Now, the front of the orbital vehicle would be a big payload door, which would open up and deploy the payload, after which it would close because this would function as the heat shield for re-entry. Now, after being on orbit for 24 hours, of course, the Earth would have rotated all the way around. It would perform its re-entry burn and return towards the launch site and again land with the assistance of parachutes and airbags. So it was a really well-developed concept. There are other concepts that they tested or made animations for. There's one that I like, which looks like it's kind of like a rocket-powered quadcopter. It's very Kerbal, but presumably they switched to a more traditional design because they figured that NASA would be more conservative. Anyway, the reason why this isn't flying is because Kistler just couldn't get the money they needed. They couldn't get the investment they wanted. Part of their $200 million contract required that they get a certain amount of private investment. And I'm sure SpaceX handled that just fine because, of course, they had Elon Musk running around with lots of money. But by this point, Kistler could not find the funding they needed. And after several warnings and several extensions, the contract was cancelled after they only made about $30 million. At this point, the money then went back up for grabs. And we all know that it went to another group called Orbital Sciences, who would eventually develop their launch vehicle in the form of the Antares. The Antares, I'm sure you remember, was the one that exploded about 8 seconds after launch, and it too was using these NK-33 engines. Now, the other side of Rocketplane Kistler is, of course, Rocketplane, and they were originally founded in 2004. They wanted to do something like Spaceship One. Their vision is basically a Learjet with a rocket engine strapped to it. They wanted to take paying customers up to 100 kilometers so they could see the curvature of the Earth and experience zero-G. They pitched this for a while. They have also pitched a version of the XS launcher, the ability to launch small satellites from a space plane. But yeah, they also have collapsed under various financial troubles, and their assets have been sold. Both companies still kind of exist on paper with the rights to the technology, but I don't think anything is seriously happening with either of them at this point. And then, of course, there is that problem of the Kistler K-1 being powered by engines whose reputation has been tarnished due to a slight rapid unplanned disassembly. Regardless, this is an interesting path not taken. Sometimes I wonder how the commercial space transportation field would be different if Kistler had managed to get the money for their launch vehicle. Would SpaceX have been able to compete? Who knows?